Example 4, fluid mechanics, chapter 7. In 1938, Howarth proposed a linearly decelerating external velocity distribution as ux u0 as a theoretical model for laminar boundary layer study. Use the Thwaites method to compute the separation point. Thwaites method, which has a formulation to compute the separation point. X separation and theta 0 for and compute with the exact computed solution. Also compute the value of CF at the condition x on L equals to 1/10. First, we should write a relation for calculating the momentum thickness to calculate the dimensionless factor gamma that can be provided as the separation point. At first, we have to calculate this relation, which is equals constant velocity decrease, pressure increase, and the pressure gradient is adverse throughout. Now the integration, so velocity decreases, pressure increase, and the pressure gradient is adverse throughout. So the integration form for the calculating the momentum thickness is this relation. u6 integration of u5 dx. We have the relation for u, which is u0 1 minus x on L. With integration, we can calculate theta 2 a square, theta 0 a square u0 on u kinematic viscosity on and integration of u5 dx. With calculation and simplification, we can obtain theta 2 theta square equals to this relation. So gamma can be calculated minus this is the gamma dimensionless factor gamma, which used for gamma separation, equals to minus now we can have an equality with previous relation. So x separation is on L this is less than 3% higher than exact solution and the computational effort. To compute CF, he shows first to compute CF at x for L. We should first compute the gamma for CF with gamma at x. This relation equals to the we calculated before here. One-tenth minus 1 so we now calculate dimensionless factor gamma, which can use for calculating the shear parameters from the relation shear gamma plus and now we can calculate the CF S equals to 1 second of CF Reynolds theta. So now we can get S equals to calculated as the relation is Reynolds theta. We should now calculate Reynolds theta to obtain CF. We can compute Reynolds theta in terms of Reynolds L from the equation of theta squared on L2 on Reynolds L So now we can calculate. We have Reynolds U L multiply to nu multiply to theta S square L square. We can write the Reynolds theta we can write U L on nu multiply to theta square L square. To form a Reynolds number, we should have U2 theta 2 on nu 2. We have theta here, theta square here, U and L multiply to nu on U multiply to L. So we have Reynolds theta A square multiply to equals to U L which so we have also Reynolds here Reynolds L. Now we can calculate Reynolds theta. Reynolds theta is QRT root square of Reynolds L. So we now have S factor which was Reynolds theta which is obtained here Reynolds L and Reynolds L equals to UL on nu which replacing to the relation CF So we can have an expression for CF is a function of root of Reynolds. This relation is for the friction coefficient as a function of Reynolds, L, not Reynolds, theta.